Hey guys, I wanted to do a video. Several people have asked. I've taught it a whole bunch and I really love teaching it. But several people have asked if I would do a video on SQL. This would be an introductory video. Obviously, I will do more later that are much more advanced, in depth, and we can get into some kind of crazy query stuff and really kind of get into it. But right now, this is just be an introduction. Get everybody familiar with SQL, what it is, why we use it, how we use it, the basic structure, things like that. So to begin, I just wanted to kind of start off at the very, very beginning and really talk about what SQL is, and then some of the other pieces associated with that. So SQL is a structured query language. It's used to, quote unquote, talk to the database and pull data out of a relational database specifically. And that's MySQL, MariaDB, which is what we use, Postgres, and Microsoft SQL, Oracle, all of these different what are called flavors of SQL. So they all are based on the same core structured query language, but they have their own minor nuances depending on the language or depending on the instance of the database type. So keywords are different in some cases. They have different functionality, obviously, and things like that. Some are more performant at one thing, or reads first writes, or whatever. Anyway, so that's super, super high level what it is. Again, like I mentioned, we use MariaDB. So MariaDB is based off of MySQL. MySQL is free, open source, very fast, very reliable, very scalable, used everywhere. It's phenomenal. It was started in 1995 and still maintained today. So it was sold in 2009 to Oracle, and the day it was sold, there was a fork made, which is MariaDB, because people don't want Oracle to ruin it. Hence, we use MariaDB. All right, so what we do here is we like to write our own statements, our own transactions, the queries, right? I mean, anybody who's been in the back end even a little bit, or talked to me for 10 minutes knows that I like the database, I like queries, stuff like that. We write a bomb. So the most complex query you can imagine that we have, right, we do them. The alternative to writing your own queries, which is sadly what a lot of people do, is they use an ORM. And what that is that it is an object relational mapping. It's a think of it like a library that allows you to interface with the database layer of your system without actually knowing SQL. So it's black box. It's like an abstraction of the database model. And what it really does, in my opinion, and this is biased because I like SQL and I like to do it myself, it really makes easy things easier. It gives you the basic CRUD super quick. You can get your selects, you can do basic joins, you can do stuff like that. But it makes harder things almost impossible. And if nothing else, it's highly unoptimized. They just kind of give you whatever it does, right? I mean, if you're writing this generalized dynamic library that converts stuff for people, you're going to come across these cases that, you just don't do well or whatever. So the most popular one, at least for Node, is SQLize. It's super popular. It's not a bad option to get you up and going if you don't spend the time to learn like this sub-language that people call SQL. But if you can do it in the database, you should do it in the database. It can process significantly faster than you can write some loop or whatever to do your lookups or whatever it's going to do. So if you can do it in the database, you should. You should avoid ORMs, in my opinion. Anyway, so enough of that soapbox. All right. So let's see, just look at my notes here so I know where we're talking about. So obviously database, it's used for pulling data from a storage location. So when we set up our system, we have these different layers of abstraction. Right? You have your API layer, you have the service layer, you have the database layer. The nice thing about setting it up this way is the service doesn't have to care where the data comes from. Right? It could pull it from our Redis cache. It could pull it from the Mongo database. It doesn't matter. It could pull it from our relational database. It doesn't care. So that level of abstraction is nice for the data source, and that's truly what it is. It's just pulling data and pushing data, writing it into the data source, and then it deals with writing it out to file and disk for storage, stuff like that. So again, we kind of touched on what the different flavors of MySQL or SQL are. MySQL, Microsoft SQL, MariaDB, Postgres. There's a ton of other ones out there, and then all have their own kind of sub pieces too, depending on the engine and stuff like that. But we don't have to get in there. So let's talk about the basics of our system and what we do. So I just want to show you how to connect to a database. So at least in PHP Storm, for everybody else who doesn't use PHP Storm, you can do it your way or you can do it the right way. So anyway, in here, so at least as of right now, this is how the tools for database connection are. It's effectively DataGrip, which is JetBrains database utility. It's the version that they have baked into PHP Storm isn't quite as complete as DataGrip, but it's pretty close, and it's awesome. So anyway, to do this, you click on the little plus here, you go to data source. We want MariaDB. As you can see, they support a whole crap ton of different database types, and you can see a bunch of these. They have Postgres, they have MySQL. There's tons of them. HeidiSQL, tons. So anyway, we want our MariaDB. So we're just going to name this guy. We're going to just say temp for this case because I'm going to delete him. Our host. If you have the database pulled down locally and set up, you can just run it from localhost, set it on your port, you're good to go. If you have it on a remote server, like we typically do, you can make the connection there. So in this case, we have it on our sandbox server. My user is dev. Our password, I copied that already. I thought I copied that already. Apparently I didn't. Hold on. I'm going to start this over so I can get that password so I don't have to remember him because it's terrible. MariaDB, okay, call him temp. I'm going to say on track sandbox here. We're going to say dev, paste, beautiful. All right, and I want my database name. So on this server, right, we run MySQL on here, MariaDB, and then inside of MariaDB, you can create your database or databases, right? It's not a one-to-one. You can have as many as you want on here, effectively, assuming your hardware supports it, these different schemas. And then you can actually get them to crosstalk. So I could target one or the other, depending on what I'm doing, in certain situations. You do have to make the database connections and stuff like that, and then inside of there you can do some fancy stuff, but anyway, all right, so this guy is on track sandbox. It is our database. I always test the connection just to make sure. All right, and we got a failure for some reason here, and that's why I test the connection. Lovely. Okay, perfect, succeeded. We apply this guy, hit OK. You can see temp, he's synchronized with the server. I expand this guy, boom, there's my database. There's our 100 and I think we're up to 7 tables for on track rest, which is beautiful. Okay, so super simple to connect it up here, get everything up and going. It's really nice. So let's talk about SQL. So what it is. It's it's awesome. I love it. It's a very fast, functional, performant way to pull data for your application, your process, whatever, your script. It doesn't matter. So with this, the basic structure always starts with a select. Well, not necessarily. It depends on what you're doing. But a read starts with a select. So there's a few different keywords that you have. So you have select, you have update. Let me get rid of this guy. You have update, which obviously updates your database table and columns, whatever you're going to do. You have an insert, which is inserting or writing into your database in that way. You have a delete, which is also a write, pulls it out of the database, it deletes that row. So I guess that's probably important to talk about too. It's the way that the structure here is set up. So you have rows, right? Row 1, 2, 3, and then you have columns. All of the columns relative to the database table. And it's just this giant two-dimensional matrix of stuff. Whatever you want it to be, and it is awesome. So formatted beautifully, you can do whatever you want. So it's your basic view for a table. You can create your tables. You can create what's called a view. You can create temporary tables. You can create temporary variables or long-term variables. A whole bunch of stuff. But again, introduction. So we're just going to talk about this. So if we look at this guy, you can see our columns. Here's all of our columns with the types that we have associated. Most of our numbers, in this case IDs, we store as a big int 20. It is important to put the 20 depending on which system, operating system you're on. The default is different, whether it's signed or unsigned. We put auto increment on our keys, so we don't have to worry about that. We also set these guys like not null, stuff like that. So it has to be there, it has to exist, and that is the primary key. And we'll get into keys in a minute and all that stuff. But so you have a varchar, which is your variable character. Then you give it a length. You have medium text, which is blob storage. So if you're storing an object or something like that, in this case we don't have any in metadata there. But if I have something in, something else, I might have some metadata stored somewhere. I did one today. Site CMS. So you can see this is just a big old object stored in here and a bunch of these things for our use case. Anyway, that's kind of what they are. You have date times, you have all sorts of built-in types that are specific to the database, but they do correlate and correspond to your regular TypeScript types as well, with your numbers and strings and all of that. Okay, so that's the initial database keys or keyword that starts off your stuff. Let's see. Let's talk about structure here. Structure. So we have, I mentioned keys. So we have the different types of keys that you have. You have a primary key, which is the primary identifier on that specific table. Each table should have a primary key, unless it's like a map table where you're kind of creating this many-to-many relationship. Obviously, as this is a relational database, relationships are important, so you want to have ways to map those and manage that relationship in a structured way. And it's really important to set your database up properly, so you have the right architecture that's going to drive the rest of your app. Because it's all data-driven at the end of the day. Yes, it can look pretty, but if you have bad architecture, you have bad data, it doesn't matter how pretty it is. It's going to suck. So you have your keys. That's primary key. Again, primary identifier. It is also what ties two tables together. So your primary key is also the foreign key on another table. So in this case, for Site CMS, we have our ID, which is our primary key on this table, but we also have company ID, which is a foreign key to, you would guess, the company table, which is the ID on that table, which is the primary key on the company table. You also have composite keys and alternate keys and these other things, but again, it doesn't necessarily matter. Those use cases are pretty far and few between. Primary key, foreign key are what important for now to begin with. And that's really how those relationships exist. So one cool feature of this guy is we can actually go in here and I can do a diagram, which I think is going to be terrible with this database because it's huge. But can see this thing is monstrous. Anyway, super brief, right? There's our company, and this is how all of those relationships to the company exist here in this giant monstrosity of a database, and how all those go. And then obviously some orphan tables down here and some other stuff. So, but that's how those relationships exist, which is super cool. Anyway, and it helps performance too. So, along with keys, you have indexes. And indexes are a pre-assortment kind of your table. So you set your index. I could set it up by what I want it to sort by, company ID, ascending or descending, depending on what I'm doing. And what that does is it lets the optimizer. So when you execute a query transaction in the database, query, right? It runs through the optimizer of that engine. So you have each engine can do different things in different ways for different reasons, and they're good or bad at some things versus others. And as it runs through that optimizer, it creates a query plan, and your indexes help with the query plan. It helps understand the relationship that you have in your tables, so queries can run faster. You can get a quicker transaction to take place. Your query plan is looking at less rows and or columns and views and whatever else you're doing in your query to get what you're asking for. So I think that's probably enough of the initial structure of how it's built and what it does and things like that. So let's get into writing some queries after forever. Okay, so the way that this works is, like I said, you always kind of start off with your select. And this is where you ask what you want. This is it. Give me back these things. So for example, let's look at our user table. I think we have a few people in our user v2 table down here. Just to see the columns, I like to have this open. I almost always have my database tool open, and I'm using, viewing it, whatever. It's important to know what's going on and how this is structured, how it exists. So I say the select is give me these things. I want to see these things. So if I say select ID from the user v2 table, so it's saying give me all of the IDs that I have in this table. This is your most basic query you could have, right? I execute this guy, and voila, I have 39 rows in my table right now. Super fast, super nice. There we go. Again, basic syntax is select or give me these things from here. So one thing you'll see a lot is our select star. I write the query as I think about it. So I select everything, select all from user, execute that guy, and now I have all of the rows and all of the columns from user. That's really what it's saying, is give me all of the rows, all of the columns from this thing. That's it. Again, if I want to narrow this guy down, it's a comma separated list of whatever I want. So I want this, I want first name, I want last name, and I want their primary email from user. There we go. There's all of our users from here. So if anybody's watching this and wants to spam a whole bunch of people, there you go. There's a whole list of 39 people that you can spam. Mainly this one. Anyway, so again, it's super, super simple to start with. It can be extremely complex. I'm not gonna sit here and say that it's the easiest thing to get really good at. It's hard, and it takes a lot of time, and you have to think about the way that you're going to address your question, because that's really what it is. You're asking questions to the database. 90% of the time is reads from your database. You are asking questions all the time. How does this work? Give me these users. I want this view. I want the subset of stuff. So it's really how you approach what you're doing there, what you're asking. So to go on this, let's say I don't want all the users. I want the users, where their first name has, I don't know, an A in it. So let's just do this. You throw some wildcards in there. It's just your percent signs, and I want an A. right? So I'm using the keyword like, which is kind of like the contains or includes, and then some wildcards. If I limit this wildcard, it has to start with an A. Now, if I put that back, it can have an A anywhere, or the end, or whatever. And I can continue on. It has to have an A somewhere and a B. It doesn't matter. It's kind of whatever you need for your use case. But I want everybody who has an A. Cool. I have 22 rows of people who have an A somewhere in their first name. Cool. Not highly useful, but it could be. If somebody's doing a search or something on a user table in the admin portal or something like that. So that's truly what it boils down to. We wrote a little bit of a, system with the pagination stuff that'll transform what you ask into queries, kind of like an ORM, but it's internal. We wrote the queries. We have control over it. We can expand it. We can kind of do some of the stuff to help. Anyway, so awesome. So now I have every user where their first name has an A in it. But, I know the user just entered, the person I'm looking for, right? They just entered. So the way that the default in your queries is ascending always. So you don't have to put it, it's default, it's there, whether you like it or not. It's always ascending first, usually by ID. But if I want to change that, I can say order by, in this case, I want to say ID descending, order by everything descending. So this is going to flip my list. This is a sort. But again, this happens instantly, or mostly instant, within 46 milliseconds, which JavaScript is not going to do that fast. So that's your sort, right? So you have ascending, descending, random, none, whatever. There's tons of stuff you can do, but you're almost always going to use ascending, descending, or random. Random is most likely not, unless you're getting like a comparative list or items like this or something like that. Okay. So you can also do, I don't care about the order. Let's say I want to group by, I don't know what I would group by in this case. I want to group by first name, because I have some duplicates in here. You see, I have Sarava a couple of times and stuff, Herschela and stuff. So let's group by that. Cool. Now we have 14 rows instead of our previous, 22. So cool. We have some duplicate names. That's great. In there for some reason. So those are kind of your basic keys that you're going to use in your queries. Is this structure? And it's, again, if just how I think about it, I talk to myself when I'm writing queries. What am I asking? What do I want to know? And it needs to become the way that you think about it. So some of the most important parts for me about writing SQL, writing good SQL, is how you approach the problem. If I want to get the users, right, I could, if I wanted to, I could start in the user address and I could do some joins and I could get back to the user table to get that data. Totally would work. It's not going to be as fast because I'm doing some weird stuff. And then the real problem, though, is it's going to make your subsequent queries or anything that you try to add in there weird, because it's not your primary focus. That's always the question I ask myself, and I ask everybody when I'm helping them with queries is, what's your primary focus? What are you actually asking the question about? Like if you're asking about messages in some messaging system, well, ask about the messages. Don't ask about the system and then some weird way get through the messages. Ask about what you want, and then from there you can add pieces in to refine that scope down. And that's really kind of what your where clause here is doing. It's going to refine what you're asking about. It's going to reduce the scope. So in this case, I'm saying the only scope I'm looking at is the user table. So the only scope that I can reduce on is the user table, and this is where joins and things like that come in. So in this case, I don't have any address information in here. Okay, well, if I want some address information, I can't just ask about the users. I have to ask the user address. So that's where addresses live in this database. It's also why it's important to know your database. So now I can, if I join this guy, I can join user address here, except I don't like aliases, so I don't do them if I can avoid them because they're annoying. And they break things. And they make things confusing. 9 times out of 10 because people do stupid things like a U for user address. Pet peeve. So now, in here, I can ask questions on user address. Now, I know that this is going to fail if I execute this query, but then I'll do it and then I'll tell you why. So, cool, failed. Column ID is ambiguous. What does that mean? Well, that means that user has an ID and user address has an ID, and it doesn't know which one I want to see, which one I'm asking my question about. Show me an ID. Well, which one? I can't show you an ID that's in 2 places, so you have to pick. So in this case, I'm going to say give me the user ID, and now I get the user ID. If I wanted the user address ID as well, I could say give me the user address ID as well, and that's going to give me both IDs. Now you can see I have user ID, I have user address ID. Now, I don't want to have the dot in there, the delimiter, so in this case, I can give it an alias, and this is really where it's only acceptable on what you're asking to get back, in my opinion, where you have those. So I would say user address ID, and I would say user ID. So you can do it this way with just next to it, or you can say as. I never say as, because I don't. I should, but I don't. So anyway, now you can see my response down here. I have user ID, I have user address ID, and the other stuff that I asked about. So now, which is cool, because now I'm joining this relationship. I'm saying these 2 tables have a relationship together. And the way that this works is I say join. This is an inner join, right? Same thing as just a join. They're synonymous. And I'm saying join this table on these fields. And what that is actually saying is I have all of these rows from user, and I have all of these rows from user address. Stick them together at these spots where these things match, where they're equal, right? So it's just doing this comparison, saying where these things are equal, put them together. And now I have a left side and a right side because I'm putting these 2 things together. And what this is going to do is let me ask questions about both tables. And I can aggregate stuff, and I can count, and I can do all this fancy stuff. But it all starts with understanding what this is doing and how it builds that table. Because truly, what's happening is you're broadening your scope of what you're seeing, or what you have access to, broadening the scope from just users to user address. Now, I say that, but it's not that straightforward in the way that it's just a join. So you have a few different types of joins. I'll show you this guy. So you have your join, inner join, whatever, same thing. And this is just going to say where these things match. Give me that response. So you'll notice our response down here reduced our scope. We went from, 14 rows to 4. So we only have 4 people in our system with an address, which is what this is saying. Again, I can remove this guy. I can get rid of my user address because I'm no longer asking questions about user address. And there's my 14 people back. Or there's my 4 people. Only 4 people have addresses in the database. They have a lot, but the user IDs, there's only 4. So anyway, good way to see that stuff and what it's doing. But back to our joins, where I don't know that one. So you have the inner join that says, give me these things where they match. I have the left join that says, give me the things that exist in the left table, right? The left table here that I'm doing, and the stuff where they match. And then you have a right join that says, give me all of the stuff in the right table and where they join. So to see that, we can say join. We can say left join. Cool, there's our 14 people back. You're going to notice that we have user addresses that are null because they don't exist. There's no relationship there. These people don't have an address in the system at all. So, but we still want them, right? That's the whole point. I still want to see these people whether they have an address or not, I don't really care. It's cool if they do, great, I can do that. If they don't, that's good too, because I know that they don't have an address and I can render whatever different that I want. So that's going to give you your left join. Now if I change this guy to right join, what do you think is going to happen? Oh, cool. We have the relationships, because that's how the relationships work. We don't have any addresses that don't have users. And we restrict that in the database with our keys, where we say things have to exist. We put a unique constraint on them. We put a required constraint on them, where they're not null. They have to exist. And that's what we're doing here. And that's why your right join is the same thing as your inner join in this case, because there are no user addresses that don't have users, because that would be dumb. But it's useful if you want to find where orders might be orphaned, or messages might be orphaned, or things like that, where I have these messages, but there aren't users. Cool. Right join works great. It'll give you a reduced scope of where messages don't have users, and you can find those and do whatever you're going to do. You can do it other ways too. Right? There's a whole bunch of other stuff that you can do to get that same data. But anyway, so that's really it. It all kind of stems from this concept of understanding how you're asking the questions. And again, it's very much I talk to myself about queries all the time. Seriously, it's embarrassing. It's pretty great. But it helps kind of flush out what you're asking your questions on. So I know this video is getting a little long, so I will sum it up real fast. But there's a whole bunch of other stuff that you can do. I can do counts. So real quick, if I want to say how many people are in my table, type how many people are in my table with A's that are by this grouping. Cool, there's 2. And if I want to group by that, and then I want to do an order by, let's get this, so count, order by count, descending. Now I'm going to get the order flipped. Anyway, there's a whole bunch of other things that we can do. We can do between, which gives you a range. You can have a count. You can show you. You can have the like. You can say, her first name is not like that thing. And that's going to give you the people whose first name is not, that doesn't have an A in it. Whatever it is. See first name. Cool. That's who doesn't have an A in their name that has an address in the system. Anyway, so you can do all of this stuff. This is off of a static table. You can do virtual tables that are created dynamically. We can get into that in another video. And with aliasing. Anyway, there's so much to learn. Anyway, this was just an introduction. Hopefully, it was helpful. It just kind of gives you a view into the way that I think about them. Like I said, some of the most important parts are understanding what you're actually asking the question of. This is not your regular code. This is not how it works, and that you have to understand that is not how this works. This does not work in the same conditional ways that your code does. This is reducing a view or expanding a view of data, and then knowing what you want and how to reduce or expand things to get that stuff. And it all stems from this stuff. Right? This is bread and butter. You're going to do crap like this all the time. When you get into some big old gnarly queries, cool, show me. I want to see them. They're awesome. I want to see some cool stuff that you do. I know Josh did one that he deleted, a million rows in a matter of a couple seconds. It was crazy. Anyway, so there's so much you can do. If you can do it in the database, please do. I highly recommend going into your console and do some queries. Try it out. See what it does. Especially if you know the database. Even if you don't, look at the relationships. I can look at this guy and I can look at the keys and I can say, okay, cool, this is the primary key. He has this user address ID, unique index, right? Which is going to tell me that there's this foreign key to the user address table. Or on the user address table, that is the user ID to the user v2 ID. Cool. Now I know that relationship exists. Let me play with it and see what happens, And if that you can't look at that and see that, that's fine. look at the columns. Okay, cool. There's a user ID. Well, I know user ID is probably going to go to the user table on the ID, so that's pretty straightforward. So anyway, look at it and play with it. Write selects, right? As long as you're not writing into the database with updates or inserts or deletes or whatever, write some selects. Do it in the sandbox environment. You're not going to break anything. Pull the database down. I'll show you how to do it. And you can break whatever you want. Doesn't matter. You're not going to break anything that I can't fix and break anything that I haven't done before myself. So get into the console. Play with it. That's the only way you're going to really master what these are, what they do, is to see them. Come up with some stupid use case like this. Like, oh, cool, I want to see the users with addresses. Okay, do that. Or whatever. It doesn't matter. Try to join crap that can't be joined or shouldn't be joined. Right? If the IDs exist and match, then, well, you technically can align them. They shouldn't be because it's not right, but you can. Anyway, that's where you get super bad data. Obviously, because it's not right. But anyway, sorry, I'm rambling. It's awesome. I love it. If you have questions, let me know. If there's videos that you want to see that are more in depth, let me know. If there's a topic you want to learn about, common table expressions or stored procedures or whatever, cool, let's do it. Let's talk about it. I'm happy to teach you guys whatever you want to know, but I have to know what you want to know. So that's my little plug for Red Sky University. So anyway, okay, thanks guys. Hopefully it was helpful. See ya.